And welcome, my dear grade 9 elite students, to today's session. This is one of the most requested videos on my channel by most of my subscribers and viewers and students of grade 9 elite, which have been requesting me for a long time for part 3. So here I am with the video on your free response questions. That means these are the questions wherein you have to show the steps and the working. So this is a very important session. Make sure you watch it till the end. Now part 3 is a big long video, so I will not be able to upload it in one go, so I'm going to divide it into 2 parts and upload. So this is going to be the first part or the first video on part 3, and there is another video that is going to come inshallah tomorrow on part 3 for the second half of the free response question. So stay glued me till the end. A very important session, so let's get into the video and see what we have in store for today. Part 3, which is going to be the free response important questions. In this slide, I have put a screenshot of my channel analytics, which shows the watch time from my subscribers. So here it shows that most of you who are watching my videos, who are benefiting from it, have not yet subscribed to the channel. It's a majority, 79.4%. And thank you for all of those of you who have already subscribed, the 20%. Let me remind you here, a gentle reminder, because it's a big motivation for me. It won't cost you much of your time. Just you have to click a button on subscribe, and it will really motivate me to make more and more content for you. Also, don't forget to hit the bell icon so that you don't miss my upcoming videos before your exam. So let's get started and get into the video now. The first set of the questions that we are going to be solving one by one are on the law of sine, law of cosines, and the right angle trigonometry. So you see questions 20 to 24. We are going to be solving them one by one. So let's solve question 20 first, and these are pretty important questions. Especially I feel out of this slide, question 21 is very important. So you should know how to show the steps while you are writing your answer. This is going to be a pen and paper based test, not online, so you have to show your working and steps. Okay, so let's do question 20. Here we need to write a 2-column proof to prove the law of cosines, and the figure is already given to you. So when I say 2-column proof, or when you get this kind of a question in your ministry exam, it means you have to first show what is given in the question. So altitude of triangle ABC is h. So this triangle ABC is a normal triangle. However, when this altitude divides that big triangle into 2 triangles, what you get is 2 right triangles. So you can see here carefully. So we are going to use Pythagorean theorem definitely, because 2 right triangles we have. So we are going to apply that in this question. Also, you have to prove a square equal to b square plus c square minus 2 bc cos a. So the angle that we are considering is angle A, this one. And cos of this value we are going to take. Okay, so we are going to use a little bit of trigonometry, SOHCAHTOA. So you know Ka stands for cos. So cos of theta, or cos of an angle, is going to be equal to adjacent divided by hypotenuse. So this is what we are going to use. So let's look at the proof. This is a 2-column proof, means where you have to show all the steps. You first write what is given, proof, and then the proof. And for each step of the proof, you have to give a reason. Why do you say that? So here h is an altitude of triangle ABC. The reason is it is given. Then you know altitude separates into 2 right triangles. So when you see 2 right triangles, as I told you, very important theorem called Pythagorean theorem will be applied. So if you see, this is the triangle, one right triangle. So in this right triangle, if you see, the hypotenuse is BC equal to A. The height is, let's make this point D, CD equal to H, and the third side is BD equal to C minus X. So if we have to apply Pythagorean theorem, then we would say the square of the hypotenuse, that means the square of A, that is A square, is going to be equal to the sum of square of the other 2 sides. So first step is Pythagorean theorem. After that, you open this identity. We are using a little bit of algebra, a minus b whole square. This identity is a square plus b square minus 2ab, or you may write the minus 2ab in middle, doesn't make a difference. So I'm going to apply this identity here for c minus x whole square. So what will I get? C square plus x square minus 2cx. So they have written here, I'm going to change the color in this form. So we have done substitution of the algebraic identity. Now when you do that, what you get here is x square plus h square. Now look at the triangle again. We are now looking at this right triangle, triangle ADC. If I apply Pythagorean theorem here, again the same theorem but for the different sides. So hypotenuse is opposite to 90, that means b square. So b square is going to be h square plus x square. That means I'm going to substitute x square plus h square with b square. I can do that using Pythagorean theorem. So this step number 4, reduces to step number 6. Okay, now I'm going to use the definition of cos. That means cos theta is equal to adjacent upon hypotenuse. Now which angle we have to take? Cos of A. That means this angle. So what is cos A using trigonometry? Cos A is going to be adjacent. Adjacent is the near one, that is x over h. This one. So wherever there is, x over b, hypotenuse. Hypotenuse means the opposite to the right angle. So wherever there is x over b, we can put this value, or if we cross multiply, this becomes, the value of x is b cos A. So now in place of this value, I'm going to put that value for the angle. So this comes out to be, after substitution, a square equal to c square minus 2bc cos A plus b square. So we use substitution, we use commutative property, and we get the last step. So that's how you do the proof for law of cosine. Okay, let's solve this question. Here we have to find the value of x. The figure is given here. So this is not a right triangle. So we are going to use cosine and sine rule for solving it. Now you are given this marking. This and this side is equal. So this is going to be also equal to 6. Let me mark this angle as theta. Now I'm going to take, do the markings for the triangle ABC. This is, for example, D. Then I take triangle ABC and I apply the cosine rule. So in triangle ABC, the cosine rule tells you that cos of theta is going to be equal to 6 square plus 5.9 square minus 2 times 6 times 5.9 multiplied with cos theta. Now I'm going to just correct this a little bit. So I can write here the side 6 square. So what did I do actually? If you see angle theta, the opposite side is 6. So this 6 square is going to be 6 square plus 5.9 whole square minus 2 times 6 times 5.9 cos theta. This is the formula that you use for cosine rule. Okay. Now out of this, I will take out the value for cos theta because that is the only unknown. Other things are given. Also your 6 square and 6 square is going to cancel. So cos theta is going to be minus 5.9 whole square divided by 2 times 6 times 5.9. So this is going to be plus now because I'm going to change the sign. Now if you simplify, this comes out to be 5.9 divided by 12. So theta is going to be cos inverse of 0.496. This is the decimal, so this comes out to be near about 60 degrees. So the angle theta we have got now. Now we are going to apply sine rule. I'm going to apply sine rule again in this triangle ADC. So sine rule in triangle ADC. So what is sine rule? Sine rule says that sine of an angle divided by the side opposite to it is proportional to the other one. So if I take this angle theta, that means sine 60. So sine 60, what is the side opposite to it? The side opposite is x, that's what we need to find. And if I take this angle 68, the side opposite to it is 6. So sine of 68 divided by 6. Now we can cross multiply to get the value of x. So x is going to be 6 multiplied with 0.866 divided by 0.927. We are simplifying. I have multiplied 6 with sine 60. Sine 60 value is 0.866 and sine 68 value is 0.927. So simplify this. This will come out to be 5.60. So the value of x is 5.6. Round off to 1 decimal place. That's how you get your value of x. So reflect on the question. We have applied sine and cosine rule to solve for the value of x. Next question is explain why Pythagorean theorem is a specific case of law of cosine. So first we are going to write the law of cosines. A square is equal to b square plus c square minus 2bc cos a. Now Pythagorean theorem, you know, is valid only in a right triangle. That means angle A would become 90 for a right triangle in order for Pythagorean theorem to be applied. So is Pythagorean theorem a specific case of law of cosine? The answer is yes. Why it is specific case? Because the case in which angle A becomes a right angle, that means it is a right angle triangle. So cos of A is going to be 0. That means this term is going to be khalas, 2bc cos A, if you put the value here. So what is left? A square is equal to b square plus c square, which is nothing but your Pythagorean theorem for a right triangle. So I will write here in case anyone has forgotten. This is the right angle. The side opposite to is the hypotenuse A. Other two sides are BC. So if A BC is a right angle triangle, then a square equal to b square plus c square. The square of the hypotenuse is equal to sum of square of other two sides. This is what is your Pythagorean theorem. So same thing is written here. The law of cosine relates the measure of two sides a and b of any triangle to the measure of the third side. Now this cosine rule is valid for any triangle, not necessarily right triangle. However, when you are going to look for Pythagorean theorem, you will take the angle to be 90, and that's when cos 90 becomes 0 and the equation reduces to Pythagorean theorem. So answer is yes, Pythagorean theorem is a specific case of law of cosines where the angle is right angle. Here I have pasted the key concept or the formula sheet for law of cosines and sines in case some of you have forgotten. So when I say law of cosines, it means that the ratio of the sine of the angle to the side, this formula is valid. So angle A, angle B, angle C, capitals are the angles, small a, small b, small c are the sides. And when I say cosine rule, it relates to this kind of a thing. So draw and label a triangle that can be solved by using the cosine rule. Now, if you remember, those of you who have studied from me, we use the law of cosines for AAS or ASA triangle. That means if two angles and one side is given, or two angles and the included side is given. So such a triangle you can solve using law of cosines, using this formula that you have been given here. And law of cosines can be solved using for triangle SAS, where two sides and the included angle is given to you. Okay, now there's one more question, question 23, which says what methods can you use to solve a triangle? So the answer is same. The methods that you can use to solve a triangle are the two, which is sine rule, cosine rule. I have already put the concept here for you. So same answer is going to work. And remember, for sine rule, the formula is written here, and sine rule can be used for AAS or ASA triangle, and cosine rule can be used for SAS or two sides and included uh, angles for the triangle. So this is the answer for these questions. 32 to 36. So here you are given some word problems. You have to read them carefully, highlight the important information before you can solve them. We are going to use basic knowledge of trigonometry and your concepts of angle of elevation and angle of depression. That is the application of trigonometry for solving these questions. So there are two people, Terence and Rodrigo. They are trying to determine the relationship between angles of elevation and angle of depression. So I hope you already remember from your classes that angle of elevation is always equal to angle of depression. This is the relationship that both the angles are equal. So this guy Terence says that if you're looking up at someone at an angle of elevation, so when you're looking up, you always have angle of elevation. When you're looking down, you have an angle of depression. So he's saying that both the angles are complementary. That means if one angle is 35, the other is 90 minus 35, which is 55, which is complement of 35. So this is what Terence says, which is completely wrong. And in this question, you need to find the error. So the error is definitely that Terence is wrong. The relationship he's saying is of complementary. However, both these angles are always equal. Now let's look at what Rodrigo has to say. So he disagrees, which is correct, and he says that the other person would be looking down at you with an angle of depression equal to your angle of elevation. So this guy is more smart. He is correct. So who is correct? Definitely Rodrigo is correct, because these two angles, angle of elevation and angle of depression, share the relationship that both are equal. And that is going to be exactly the same answer for question 33. So here a classmate finds the angle of elevation of an object, but she's trying to find the angle of depression. Write a question to help her solve. So you have to think about what is the relationship. The relationship is both are equal. So if you already have in a question an angle of elevation given to you, then angle of depression is going to be same. There is no extra effort you have to put from your side. Next, you have to classify the below statement as true or false. Explain your reasoning. So the statement is, as a person moves closer to an object, he or she is sighting, the angle of elevation is increasing, which is definitely true. And I will make one figure, quick figure, to let you know of the same concept. So for example, the eye is here. This is the angle theta. This is the height of the object. Say this is triangle ABC, right angle triangle, and the person is standing here. Then the person starts to move towards the object. The object here is this. This is the object. The person is at this point. So you see this is the angle of elevation theta. As he's moving closer, for example, he reaches this point D. Then to look at the same object, he has to bend his neck more. So this second angle, for example, this angle I'm saying is phi, then phi is going to be more than theta. It will be more because you have to bend your neck more. And as you come closer to the object is not moving. The height of the object is same, but what is changing is the distance you have traveled. So for example, he travels x distance, and now he comes closer to the object. So therefore, the angle of elevation definitely is going to increase. Question 35 is again a very important question. Can be expected in your ministry exam. So I'm going to solve it in the next slide. It requires a bit of calculation and trigonometry. So let's solve the question on the next slide, question 35. So here on this slide, I have provided all the answers from question 32, 33, 34, 35, and 36. You can have a look. For question 35, the value of x is going to be 7.8. How it is going to be 7.8, I will explain you in the next slide with all the steps. Using trigonometry. And for 36 question, describe a way that you can estimate the height of an object without using trigonometry. So if you cannot use trigonometry, definitely you will use special triangles. So I hope you have watched my previous videos where we have talked about the two types of special triangles, that is 45 45 90 and 30 60 90. So you can use the knowledge and the formula of special triangles for solving your question if you cannot use trigonometry. So I've provided the sample here, answer here. If you cite something with a 45 angle of elevation, you don't have to use trigonometry to determine the height of the object, because the legs of the 45 45 90 are congruent, and the height of the object will be same as your horizontal distance, because tan 45 is 1. So we are going to have the same value. No use of trigonometry. Directly you can use your knowledge of special triangles. Okay, so let's solve this very, very important question. I'm going to be solving this question using the basic knowledge of trigonometric ratio, that is SOHCAHTOA. So just see how I'm doing the question. First of all, there are some values which are not given, so I'm going to randomly take some variables. Let this be y, let this height be h. I'm going to name the triangle A, B, this point C, this point D. Okay. Now this angle we don't know, but this is a right angle triangle. This angle is 90. So you can find angle sum property. 70 plus 90 plus this angle is going to be 180. So this will come out to be 20 degrees. Now this angle is already given to you 15 degrees, and the trigonometric ratio that I'm going to pick up first is tan. So first I will calculate tan 20 degree, and then I will be calculating tan 15 degree. Why I'm doing this, you'll get to know in a minute. Why I selected tan. So tan 20, by definition of SOHCAHTOA, tan is opposite over adjacent. So the side which is opposite to this is h, and the side which is adjacent is y. So for tan 20, for this right triangle ABC, I will write here, this is triangle ABC we have taken, and this is triangle ADC, the big triangle. So for this big triangle, this value tan 15 is going to be h, the same h over y plus 2, or 2 plus y, whichever way you like. Now what I'm going to do, I'm going to use cross multiplication. I'm going to cross multiply, and I will get the value of h. So h is going to be y tan 20 degree from here, and from here h is going to be y plus 2 tan 15 degree. Now both are equal. This is also h, this is also h. So from equation 1 and 2, because the left side is equal, h and h, the right side will also be equal. So y tan 20 is going to be equal to y plus 2 tan 15. Now you'll use your calculator and you'll use the values of tan 20 and tan 15 degree. So this is going to be 0.3639, and this is going to be 0.2679. I'm going to round off, and the value that I'm going to use here in this question is nearest to round off to one decimal place, so 0.4 for this, and for this I'm going to use 0.3. So let's plug in the value. So y times tan 20 is 0.4 is equal to y plus 2 times 0.3. Now solve this equation, open the brackets. So this comes out to be 0.3y plus 0.6. This is 0.4y. So I will collect the like terms. This I'm going to move here. So 0.4 minus 0.3. The sign gets changed, and I will get the value of y here as decimal gets removed, so y is going to be 6. So what I've got, the value here is 6. Okay, now I've got the value of 6. I can find the value of h now. So to reach to this x, we have to go a long way. First we have to apply the tan ratio. From there I get the value of y. After I get the value of y, I need h. So for the value of h, I'm going to use the trigonometric ratio and the definition that h is going to be equal to y tan 20 degree. So y is how much? 6, and tan 20 degree is 0.4. So h is going to be 2.4. So we have got y, we have got h. Now the last step is to get to this x. For x, I'm going to use the big triangle ADB. So in triangle ADB, now I'm going to use the ratio of cos. Why I'm using ratio cos? I could have used sine also. Both are going to give me the same answer. I'm using cos because by SOHCAHTOA, cos is adjacent over hypotenuse. Now this is 2, this is 6, so the total is 8. So 8 divided by x. Now to get your x, you have to cross multiply, use the value of cos 15. So x is going to be 8 divided by cos 15, which is going to be 8 divided by 0.965. Simplify, and this comes out to be equal to 7.8. on rounding off. Okay, so that's how you reach to the value of x. Let's solve some more questions on Pythagorean theorem and right triangle. So the 40th question says, true or false, any two right triangles with the same hypotenuse have the same area. Now, area of a triangle, what is the formula? Let's recall 1 by 2 base times height. So does it involve hypotenuse? No, not at all. So if you have two right triangles with the same hypotenuse, can they have the same area? Is it possible? No, because area of a triangle does not require hypotenuse. That's not a condition. So base and height of the two triangles may be different. Base and height of two right triangles may be different. So even if they have the same hypotenuse, if the other two sides are different, they cannot have the same area. Okay, next is question 41. Draw a right triangle with side lengths that form a Pythagorean triple. So no need to go very deep in this question. Take the simplest one. If there is a right triangle, the hypotenuse is 5, then the other two sides are 3 and 4. This is a Pythagorean triple, simplest 3, 4, 5. Okay, why it is a Pythagorean triple? Because 5 square is going to be 3 square plus 4 square. You can check. So if you double the length of each side, is the resulting triangle acute, right, or obtuse? If you half the length of each side, what will happen? Explain. Now see, even if you are doubling or even if you are halving, will the shape of the right triangle change? Think about it. No, it will remain a right triangle. So by similarity, it is still going to be a right triangle. So if you double the length of each side, or if you even half the length of each side, will it change its shape? Will it differ from a right triangle? Will it become acute or obtuse? Not at all. So it will still remain a right triangle. So that's the answer for this. Next is question 42. Again, an important question. It will require a lot of space. We are going to solve it in the next slide. Then question 43, research incommensurable magnitudes and describe how this phrase relates to the use of traditional irrational numbers in geometry. Include one example of irrational number used in geometry. This question is not so important and out of context, so we are not going to pay much attention to it. We are going to focus on question 42 now, and we'll do the steps. We are going to be using definitely the knowledge of trigonometry, right triangles, and Pythagorean theorem for solving this question. So let's do it. Okay, let's solve this question now. Here we are going to use only one theorem but repeatedly, that is called your Pythagorean theorem. You see some right triangles. We are going to mark the figure. Let's mark it A, B, this point is C, this point is D, this point says B, this point says Q. Okay, now this X we need to find. That means we need to find AQ, and we are going to be solving it, as I told you, using our knowledge of Pythagorean theorem and right triangle. So you see here a right triangle, you see here a right triangle. So step one would be to apply Pythagorean theorem in both the triangles. Also you see one more right triangle, ACD, the big one. So here also we can apply the Pythagorean theorem. Another one is this right triangle, so there also we can apply Pythagorean theorem. Now we need to think how we are going to be solving this question. First of all, I'm going to be finding the value of AC, so I'm going to take the right triangle ACB, and in ACB I know AB square is going to be AC square plus BC square. This is Pythagorean theorem. Hypotenuse is 11.6. I put the value. AC we don't know, we keep it as it is. BC is 7.5. So simplify this. So 11.6 whole square is 134.56 minus 7.5 whole square is 56.25. That's going to be AC square. So your AC square on subtraction comes out to be, let's find the value. So we are going to subtract the two numbers. 134.56 minus 56.25. This gives me AC square as 78.31. Now I keep this here and I go to the next right triangle. I go to the triangle where you have the other right triangle. That means I'm going to now look at the triangle ACD. So in triangle ACD, AD square is going to be AC square plus CD square. So AC square we have already got 78.31 from step 1. CD square is going to be 15 square, which is adding to it 225. So this is going to give me 303.31. Now this is the value of AD square that we have got. That means we can get the value of AD from here. So AD is going to be square root of 303.31. So this is going to give you 17.41. Mark this as second equation. Now let's go to AD, this one. Now AD is made up of AP plus PD. That's very much clear. So I'm going to write that equation. AP plus PD. Now we have to go to the right triangle that you see here for finding the value of PD. So this right triangle, I'm going to now write in right triangle PQD. If I apply Pythagorean theorem again, then 13 square is going to be 2.7 square plus PD square. So from here you can get the value of PD square. So PD square is going to be, on simplification, 161.71, or PD is going to be its square root, which is going to be, I will directly write the square root here now because I have less space. So PD is 12.7. So you have the value of PD, you have the value of AD. So can you calculate the value of AP? Yes, very much. So here AP is going to be 17.41 minus 12.71. So this comes out to be, I will subtract the two, 17.41 minus 12.71. So this comes out to be 4.7. Now you have got the value of AP. This is 4.7. Already you have the value of PQ. So can you get the value of x square? Again by Pythagorean theorem. So can I say x square is going to be 4.7 square plus 2.7 square? This is going to be the last time we are applying the Pythagorean theorem. So this will come out to be 21.9961 plus 7.29, which is near about 29.28. Now this is the value of x square. We need the value of x. So last step we are going to take the square root, and if you see we also have to round it off. So the square root will come out to be near about 5.41. So I've rounded off. So this is going to be your answer. So if you see, we have applied in this question. Now I'm going to use yellow color and highlight the last step. We have applied Pythagorean theorem how many times? Let's see. This is the first time we applied. Then this is the second time we applied. Then this is the third time we applied. And finally the last and the fourth time we applied. So 4 times, that means a repeated application of Pythagorean theorem helped you to solve the question, and that is why the question is under the section persevere. Persevere means to carry on, to go on. So you have to again and again apply the same theorem 4 times to get your value of x. Very, very important question. So now I'm going to show you the final answers for question 40, 41, 42 and 43. So you can have the sample answers here. We already have found the value of x in the last question, which has come out to be 5.41. So this completes the part of triangles, Pythagorean theorem, right triangles and all of that. Now there's a little bit part of part 3 still left, but the video is becoming too long, so we are going to continue that part in another video, which is going to come tomorrow, inshallah. Thank you for watching. Don't forget to like, share and subscribe to the channel if you liked the video and found it useful. It takes a lot of effort for me to make these videos for you, so make sure you motivate me by subscribing. It's just the click of a button. And do share this video with all your friends who are going to give the grade 9 elite exam so that they can benefit from the video. Until then, this is Ms. Ruchika signing off from today's session. See you in my next video, which is going to be part 4 of the free response questions for your coming ministry exam. All the best and take care.